Please remember to sign in on the attendees list. Actually, wait, maybe one more minute, see if more folks show up before we get started. All right, do we have a volunteer to take notes today?
I can try to take some notes.
All right, thanks, Jesse. And do we have any new faces? I think everybody's been here before. Yep, pretty sure. All right, we'll move on to release planning and updates.
From the platform side, I don't believe there's been anything, at least recently. I know someone reported an issue with Inspect Builder, a bug there, but I'm still investigating on how severe it is as to whether or not we'll need a patch to go out soon.
I think we said yesterday that platform 07 is of the spec is about to be ready to release, or I don't know, it's going to be released soon, and the next life cycle will support it, but will not support Buildpacks 07.
On the back team side, we had a meeting to discuss like the new version of libcnb and sort of the features it should support. So I think we are looking at the existing Go bindings that other organizations maintain, so Packet, libpack, and the GCP one, and see which features are common and should be provided as utilities by the project. I think we also had some discussion on better structured logging for Buildpacks so that we can have uniform output when you're mixing and matching Buildpacks, and see if platforms can provide some pretty printing based on that structured logging. That's pretty much it.
Any updates on distribution or learning? Seems like no for this week. So I'll just, before we move on to the RFCs, just as an overview, we're going to spend 10 minutes talking about supported utility build packs, try to time box that, another 10 minutes talking about structured BOM format, try to time box that, and then use the remaining time to talk about the remove stacks and mixins RFC. So keep an eye on the clock. First one is officially supported utility build packs. I think that's Joe.
Yeah, I think there's two areas that need discussion on this. The first is around some of the criteria that I added for accepting a utility build pack into the project, and in particular that any utility build pack we maintain would provide some behavior or implement some behavior that's part of the specification. And so like my thinking there is that the build pack itself is just an implementation detail, and that the specification just defines like some behaviors that a build pack lifecycle or platform would support. And the build packs are one way of providing that behavior, but like other platforms, other lifecycle implementations, could do that a different way. So I kind of expected that to be a little contentious and require some discussion, but I wanted to start there because I do think I think some of the feedback I got on the RFC was that we needed pretty strong criteria for how and when we would accept utility build packs. So actually, as an example, that would probably mean that we would not accept a proc file build pack into the project as something we maintain, but it might mean that we accept something like the Paketo environment variable build pack, because I could see that being a thing that we spec, like a certain way to inject runtime environment variables or something. The other point of discussion is stack support. I had said that any build pack we accept into the project should support all stacks. Again, kind of I can see that could be contentious. Also, if stacks are going away, that's kind of a point of discussion. So I think there's a little bit of this that hinges on the thing we're going to discuss later today. And yeah, and I think part of why I'm asking about the wildcard stack support. So
on the question of whether they should be spec'd, I think I strongly agree that we should have, very high standards for what utility build packs get into the project. I think those build packs can be very well specified by the project, as this is behavior that's expected of something that implements the build pack API. The only part of it that I'm maybe not sold on is I don't know if that should be specified in the same document that specifies the lifecycle component. And like I get the argument that, well, what if you implemented a lifecycle that didn't do those things as build packs, that was where they implemented whatever profile support, right, as part of the lifecycle itself. But I think we get feedback that the specification is confusing because it doesn't kind of describe each component separately, and I don't want to kind of contribute to that. Like, here we have a document, here we have a piece of software, but they don't really match up, and it's hard to tell, how do I use this, because we don't have very many lifecycle implementations, right?
So yeah, I definitely not everything would be like, some of these would be extension spec stuff, right? Like I could see us owning project descriptor things or something like that. Definitely would not be in the core spec. They could be an extension. And I'm not even sure, like when I was sort of saying that some things might go into the platform spec or the build pack spec or whatever, like I'm not sure where different things would fit, but I would imagine it could be different. So I think I'm fine with like separate files for different parts of the spec. But the part of that worries me is like a one-to-one mapping between like a component and a spec. Like it might make sense to split it out, but that should be because it makes sense to split it out, not because we've implemented like a separate component to do that. And if we can do that, then I think I'm on board with what you're saying. I don't know if that makes sense.
Maybe there's a separation between an API and a spec. It's like, I agree that this should all be in the build pack API, and that API should be something you can consume easily, as this is the API that a build pack has to follow. But then the specification that describes the behavior of the parts that you're going to implement, right? I think that can be divided. Right now, a problem with that is that it's all one thing without kind of regard for the different stages and those parts.
So can we talk about a concrete example? Yeah, let's talk about a concrete example, because I think that would help. So like either the profile build pack or the MVAR build pack, the runtime MVAR build pack, I think are good ones, where like they have an interface. Like the MVAR build pack, Paketo people correct me if I'm wrong, but I think there's like, you can provide, or you can set MVARs with like BPE or something underscore, and then that's like the convention, and it picks them up and it sets them in the layer as like a build as a runtime MVAR. I feel like if we were going to accept that build pack as a utility build pack, that convention, the BPE underscore thing, is something we should spec. And in that case, I'm not actually sure where it would live, but like that, maybe that's worth talking about.
Wouldn't even really make sense in the build pack spec, because this is the behavior of a specific build pack, not like a build pack API
Well,
feature. I wonder if we're using.
That's what I'm saying, though. I think that's what I'm saying is like that's an implementation detail. The fact that it's a build pack thing, right? Like if the build pack is there to provide or support or implement something that we spec, and Acme platform could come along and say like, yeah, we're going to build our own lifecycle, and it's just going to have all these things natively, so you don't need the utility build packs to do it. Maybe I'm bleeding into the system build pack RFC 2 here a bit, but
I guess. Okay. I wonder if we're abusing specs in some way here. Like, is what we really want the behavior to be consistent and documented? I feel like the reason you want a spec is so that there can be multiple compliant implementations, right? And I think we're moving to have these utility build packs in the project because there are cases where there might be, 4 implementations doing the same thing in the world, and we really want one. It's sort of like we're trying to move in the opposite direction where there's a single implementation of some of these behaviors, unless you're saying that it is a really strong goal to then like have the flexibility to implement this feature in either the lifecycle or a build pack. And I would need convincing that that is a valuable type of flexibility and not just extra complexity.
Yeah, I'm describing it that way, but that's not really the motivation. The motivation for me is that as a build pack user, I don't have to worry about the fact that this is implemented by a build pack. Like, I just know that BPE underscore whatever is how I can do the runtime and environment variable thing. And the fact that it's a build pack is just not something I'm concerned about. It just works. And I think like that's why I desire the spec. Like, it's less about, although I think it is valuable, but like it's less about someone else going and implementing it a different way. Although I think that is potentially valuable.
I agree with the goal there that people using build packs shouldn't have to care about these, like where it's implemented. But I also think that people using build packs shouldn't have to read the specs either. Like, is this just a how we document it question rather than like I worry that we're speccing things just because people use it for documentation because we haven't figured out how to communicate in that way in the documentation.
Yeah, that may be totally valid.
I wonder if we're trying to use the spec as both a spec and an API definition. We want one unified API, but when we're talking about how things are specified, like imagine a spec in the future that goes through and has separate documents for the underlying layer exporting process and the caching interface, right? That's totally separate from the part of the build pack API that's provided by the builder, right? Which provides, so imagine you have all, different documents that describe, here's how the layers move around, here's the API that the builder provides to the, build packs. And in that builder document, maybe there's a section for like mandatory, I don't know, this is a bad name for it, but mandatory extensions and optional extensions. And then in mandatory extensions, it talks about runtime environment variables and has a particular interface. And then in optional extensions, it talks about whatever we want to add that you're allowed to not put into a build, right? That could be utility build packs also. Then it's not saying this has to be a build pack or it doesn't. It's just saying it's keeping those parts separate, right? Those extension things could even say at the build pack, this we strongly recommended to implement at the build pack layer instead of at the builder layer, right? And then we're still talking about a specification that's describing the behavior of components. There's not an API definition. And maybe it's a problem that it's also creates an API out of it too, and that's something else we should solve. But I think the underlying problem to me seems like our spec is, right now it serves as kind of like documentation for things we have documented. It definitely serves as an API definition, even though it's not an API. It's a thing that people view as specifying components, then it serves as a very poor thing that specifies components because it's trying to do those other things at the same time. So I think I agree that it's really, I think we agree on the underlying, these things should be required. It should be obvious to Buildpack authors. Builds shouldn't be able to not have this functionality. It should be swappable. The other components should be swappable, but it's just that we all, are trying to have the spec serve these purposes that,
Yeah.
it'd be
yeah.
better if it just did one thing.
Yeah, I think I'm on the same page. So when you say, although like some of the language you're using, I want to make sure I think the same thing, like when you say that. So when you say like the Buildpack layer of the spec or like the Buildpack API, like the BPE environment variable is something that I would want as part of the API. But I think you're saying that should be independent of how we spec the components. Is that, would you agree with that
Exactly.
statement?
I think
Okay.
we
Yeah, I'm on board with that.
clear about which API we're talking about here as well. Like we want BPE underscore, like if you said it,
Right.
this is what happens to be part of the like app developer API when they're using a platform. It's not part of the Buildpack API because it's not part of what a Buildpack needs to do in order to
Yeah,
express
I think I agree with that. I'm not thinking too hard about like where this specific example fits into which API or whatever. I'm just kind of using it generically.
It seems like maybe we can model these
Yeah.
like as if we had an actual platform spec that was like, this is what a platform needs to do. Like in some ways, I don't exactly want to do this because I don't think we need to spec these things. But if we were going to spec it, it makes sense to me sort of as like an extension of the platforms, an extension spec that platforms can choose to implement. It's like if a platform wants to provide environment variable support, it needs to include a Buildpack that does X. And that's describing like what a platform needs to do in order to expose an optional feature to end users. And then the interface that is exposed to end users, I think, is not a spec thing.
Yeah, maybe didn't follow that. So I think I can take a stab at writing this up, and then I'll probably like do some back and forth with y'all, but I think that's a good next step. And I would say the other part of this, the stack support, like let's punt on that until we figure out the stack RFC. I think it's probably better use for our time just to move on. That sound good?
Sounds good. There was one other thing you mentioned there. I forgot what it was, around wildcards. I think we could bring that up in the, because it's also the remove stacks and mixins, or we could, I'm happy to, I don't want to, we reserve 40 minutes to talk about the other thing. So if we need to extend this by, okay. So the, sorry, I lost what's the next one on the list?
Structured bomb format.
Structured bombs.
Yeah, structured bomb format.
I did not put that on the agenda, so I'm not sure. I just wanted to remind people that the pull request is ready, and if people have any comments, you can put them there.
I think as of yesterday, the discussion came up where really I was just being more curious as to what the state of the RFC was. And it sounded like we were leaning to Cyclone DX being the only first supported format, if I'm not mistaken. And I think the question that came up is whether the RFC is ready with that sort of change in place.
I think it was. So currently the RFC states that we'll support both SPDX and Cyclone DX as outputs from a particular build pack, but the lifecycle will only merge the Cyclone DX outputs. The SPDX outputs would still be there, and in the future, once the lifecycle does manage to support merging SPDX documents, like the build packs wouldn't have to update. They could just update the lifecycle and they'll get a merged SPDX bomb. So the Cyclone DX merge parts are defined and same for this behavior. I think the open questions were like, how does it get merged with the stack bomb, or the base images, basically, like how does the bomb from that get merged with the ones from Buildpacks, and the format we store it in, and how do we handle restores or rebuilds with bombs, which when we last discussed this, we said it was fine to address that in a separate RFC. And for this RFC, just to specify that we'll be supporting these bomb formats and this is how the lifecycle will merge them. But as to where it will store them and how it will restore it during a rebuild, that would be a separate RFC, since we need to move that from a label to someplace else anyway.
Was there anywhere on here where it talks about, like, I guess maybe from just my curiosity, the value of Buildpacks being able to provide SPDX as opposed to just landing on one format and kind of having them adhere to that?
I don't think it directly talks about it, but I've linked that NTIA document there, and the general like consensus is that as of right now, there's no like default or best bomb format, and typically when you're consuming these files downstream, your tools may support different kind of bomb format. So it's not just about generating an appropriate bomb, it's also about consuming them in an appropriate way. So we want to leave enough flexibility in the system so that if internally your tools only support SPDX, you can still take the individual files and merge them together and put it somewhere if your build packs want to give you that information. Because as of right now, conversion between the different bomb formats is lossy, and there's no good mapping between like, and for certain fields there cannot be a mapping because one bomb format doesn't support it. So for a minimal set of fields, it's possible to convert between the two. But if you're looking for a specific use case, or if your organization is more interested in a compliance use case rather than a security use case, one might be better over the other. So it it mostly depends on what the consumer's use cases and how they are consuming the bomb files.
And that being said, if I were to simplify it, it would be that we support both formats, but maybe we may recommend Cyclone DX because we have additional functionality on top of that, which is
Yes,
the merging aspect. Okay.
it also gives us a easy migration path, because we will not convert between the old legacy format and the new Cyclone DX format. Those files would still just be there as they were. And if you have the appropriate tools to take your like legacy build packs that are producing the bomb in the legacy format and some new build packs that are producing it in Cyclone DX format, you can try and merge them together on the app developer side, or the platform owner side. So trying to reduce the dependency in the life cycle as much as possible as to what kind of information we're like converting and possibly losing out, and we're changing between bomb formats.
Great. I think Terrence just added that question about SPDX and Cyclone DX to the RFC. I'm assuming we want to maybe have that written on there as to why we're aiming to support both?
Yes, I will add that.
I think I agree with the goal of eventually supporting whatever SBOM formats become popular that can be merged together and turned into one SBOM format or one SBOM for the image. I guess I have two questions. One is I see a merge, there's a thing in there about a separate merge bomb binary that Lifecycle calls out to that does the merging automatically, but then it also says that SPDX, and maybe I'm just missing something here, but it also says that SPDX merging isn't supported. How does that interact? So it's like, is there a different merge bomb binary for the different formats, and the SPDX one is usually missing, but if it were there, it would try to merge it? What's the,
I think that's a leftover commit I haven't pushed. That merge bomb binary should have gone away.
Okay, cool, got it. So that would be, the Cyclone DX would be baked into the life cycle,
Yeah.
but the SPDX one, Buildpacks could still output SPDX, but then that output, what happens to that output? Does it end up in?
It just ends up in layers. So if you see, I define an output path, layers config SBOM, and it'll just end up there under the Buildpack ID with the BOM extension. So it won't be merged, it'll just end up there. And if users want to take that and merge it together or do whatever they want with it, they can do that.
Does that end up in the runtime image, just next to the actual layers, or did I misunderstand?
Yeah, I think that was the current plan. Like, that's why, like, I haven't, like, one of the open questions is where it gets stored. So that was just where, like, the lifecycle will put it, and then I was leaving the export part towards the end. So, like, if we want to put that somewhere else, like using the cosine SBOM artifact format, we can do that.
I like
know.
just leaving it as a file in the build container for now, not in the app image, but in the build container, and then the platform can decide how to handle it. Because I think if we decided to norm on cosine, we'd have a bunch of problems with like manifests in the daemon case that I don't think we're ready to deal with.
Oh, yeah.
So what happens to the merged one if we're not gonna, in the RFC, if we're not gonna talk about how it ends up
I think
turning
it
into an image?
also just ends up as a file in the image, and then a platform could make that available in different ways. Like maybe in pack, it copies it out to the path that the user provides with a flag, or maybe in a platform like KPack that already has some built-in support for cosine with those conventions and always uses the registry, it could push it using the cosine conventions. But I think if we leave it to the platform, that gives us a good path forward.
I think I'm, sorry, go ahead.
I was gonna say it's similar to the report toml use case that we have right now, where we just generate it and it's up to the platform to figure out what to do with it.
I think I'm a little worried about supporting SPDX without a path to turning SPDX into the like collection of SPDX files into something consumable. But cosine actually has a way of, you can specify an SBOM and a cosine manifest in a way that lets you associate an SBOM with each layer. Like,
yeah.
And so there actually is a format that could capture. I don't think anything could scan it realistically, and so I'm a little hesitant to go that direction. But there is a format like that cosine specifies that would let us capture all of it in one artifact in a standardized way for SPDX. I wonder if, but if we do that, then it's less easy to say, oh, and it maps to this text file because that format is kind of OCI specific. So then that makes me think, well, should we actually output these in OCI format and then just not specify how they get exported into the image or whatever because of the daemon case? Or maybe it'd be better to specified this so that SPDX could be added in another RFC easily without breaking changes, and then scope it to Cyclone for now is another option I could see too. But I worry about the in-between state.
I think even as it is right now, since we have the added benefit that each layer corresponds to like a Buildpack ID and then some layer underneath it, except for app slices. So when we are generating these SPDX bombs, we are generating it under that path. So we know which layer it maps to. So even if we leave it on disk, when we eventually support SPDX, we can export it in the when we export it in the cosine format, we'll know which layers those files on disk map to. So the layer path is like layers config, buildpack ID, layer name, build.bomb or launch.bomb or whatever. And using that file on disk, when you export it as an image, you can then map which bomb file maps to which layer in the image. If that makes sense.
What if we created, just to make sort of the migration here easier in the future, what if we created a directory that was called something like outputs, and that's where we put report toml, the merged bombs, and if we wanted to put layer specific bombs, we could put them in there with a conventional name that's like, you know, layer dot bomb dot whatever. And then in a platform like Pack, we could always copy out that whole directory, which gives you more options for how you could merge things in the future if you wanted to start doing things like that without reaching around to all the different places, especially when you're working across Buildpacks with multiple APIs where their layer paths might actually be different.
I was going to ask, I think related to this, of what the value was for the lifecycle during the merging, as opposed to the individual platforms if they needed to. Like maybe I just don't understand the merging aspect of the bomb, specifically because it only relates to Cyclone DX right now.
That was also something I had brought up in the past where I wanted to delegate the merging to the platform, but the opinion was that the lifecycle should support it.
I
Is
guess
that true?
I think I still feel that way mostly. I think it's a less of a strong argument now that we're not trying to like combine Legacy and Cyclone together or do more complicated things. But I do think it puts a pretty big burden on the platform to have to keep track of like, here's the stack bomb and here's how you name a bomb for each layer and here's all the different extensions. And then each and every platform has to implement merging. Feels a little bit rough to me.
I guess I'm just thinking about it in the case where, let's say that they choose to use SPDX, right? The Buildpacks do. From a platform perspective, I'm not going to do anything with that anyway. So I'm not sure that I would be doing too much with the, you know, merged or unmerged Cyclone DX stuff. I feel like that's maybe even something for either a very specialized platform that wants to do, like, I'm only going to support Cyclone DX and they're going to do the merging themselves and specialize in that format. Or they're only going to support SPDX and, you know, display it in some other format. So I guess maybe I'm just not entirely sure that there's an alignment of what the lifecycle is doing and what the expectation of the platform is.
Other argument for putting it in the lifecycle is for consistency. Like when we're saying, oh, maybe one platform only cares about SPDX and one platform only cares about Cyclone. Well, that gets tricky when those platforms are not always providing all their own build packs, right? We have a goal of build packs running in different platforms and producing consistent results. So if it was on the platform to merge the bomb, you could get a really different bomb depending on which platform you run on, which could be weird.
Pack is going to want to parse this and then do validations against it on rebase and things like that. It's not just like some metadata that a platform owner cares about. The data may get used extensively by the tooling of the project provides. And having it separate makes that tooling more complex because now we have to have the tooling, parse multiple files for each layer
Okay, and then in this case, we're not talking about the build packs providing their SBOM in, let's say, SPDX, right? We're talking about the lifecycle providing its SBOM for what the build packs were that were being used. That's what Pat would care about, right? Like it wouldn't care about the SPDX formats provided by the build packs. I hope that made some sense. Like there's going to be like a lot of SBOMs generated, some by the build packs, some from the lifecycle. Am I getting that?
The life cycle doesn't really generate an SBOM, it only merges, right? Like the stack brings an SBOM, Buildpacks write SBOMs for the different layers, and then the life cycle sort of just stitches it all together. Life cycle doesn't know what's in the image.
Well, I
Other
guess
than like it could describe the launcher, like maybe it should do things like that, but other than that, no.
I guess that's kind of my rebuttal for Steven's statement, right? Is if the build packs are providing it, then now as a platform, I have to care of whether they're an SPDX or SitePointDX. And that seems to add a little bit more complexity if I'm really going to try to use them.
Just as a reminder, we're quite a bit over time. I just noticed.
Yeah, let's move on to the next one.
Still very interested in getting to a resolution on this though. Maybe something we can come back to at the end if there's time after remove stacks and mixins. So the next one is mine. Remove stacks and mixins. I'll go ahead and share my screen because it'll make it easier. Unlike the Docker file one, this doesn't take 2 years to load. Give me 1 second. So this, I made some changes to recently. The big overarching changes, it still gets rid of the word stack and mixin. It still replaces mixins with more canonicalized metadata about Linux distributions, whatever. Instead of using custom labels for each field for the OS and architecture variant, which I realized was missing, it uses fields in the config blob that already exist that hold that data that are mandatory, that must be there for every image. The labels would go in the config blob also. I see no reason for those to be labels. I think they can just be fields in the config blob. The config blob does have a version and features as well that I didn't use because version it's used by other images already to use values that aren't exactly these values. Currently, these 3 fields are always Go OS. They're defined in the OCI spec to be Go OS, Go Arch, and the equivalent of Go ARM because variant's only used for ARM right now. But the other field, the version and features fields are not specified to be ID and version ID. So I did introduce those as labels, if that makes sense. But labels are in the config blob next to those other properties in the same JSON document. What else did I do here? I said os.version in the config blob can be used with, it's okay if it's populated, but it's not used by the lifecycle for anything. The mandatory fields are OS and architecture and variant if necessary, but it doesn't have to be there if it's a non-variant supported architecture. The other fields are optional. Is this question answered here? I think that was answered. Sorry, going down here a little bit further, trying to remember what's going on. I took out all the packages logic, I think in the revision before this, just as a reminder. So it really is, a target really is only that metadata above. I think one question, I think it's somewhere in here, maybe it's not a comment on the text anymore, is what if you don't specify any targets? I originally interpreted this sort of Joe's wildcard question. I originally interpreted that as, what if I need to specify a build pack that works on Windows and Linux at the same time? Because those are the only two containers supported, operating systems. Or what if I need to specify a build pack that worked on multiple architectures at the same time? Like it was okay on ARM and x86. I think it'd be really easy to extend this to support it, because these targets are not, they're individual images that get built, right? And so this could just be a list in that case, right? Just like name and then versions here is okay. And this is distributions, not distribution, right? But my concern about doing that is that an OCI image has, those fields are mandatory at the top and must be populated. And so I'd kind of rather generate multiple copies of it, of the same build pack, marked for each architecture and OS if necessary. And then it'll just work automatically, because manifest indexes, capture each one independently in the same repo, and the right one would get pulled for the architecture you're on. And so I don't like, yes, we could like build one for x86 and ARM, and then put x86 on it and have the config blob lie about it, and then capture that it also works on ARM in a label. But that feels kind of complex, and I'm not, it's something we could add later if we need to. But I think the concern that Joe, I think maybe I misunderstood, was more, what happens if we don't have this targets list? Can we make it easy for people who are just writing simple build packs to not have that? And I think it's fine if we just assume this, if targets list is empty, just put Linux x86 64 in there if there's an empty list, and then a build pack is by default a Linux build pack for x86. If ARM
like
takes over the
that.
world, sorry.
I like that much better than everything, where it's like, I think if the default, if you did nothing, was, you support all 4 variants of ARM and everything else and Windows and whatever variants of Windows there are, like, that's probably not the default case, right?
It might get weird if ARM takes over the world, and then, but I think we can deal with that later.
We could change it later if we need it.
I think it's going to be weird for a lot of software.
Yeah, I think I would defer to y'all on if it makes sense for that to be a default. I definitely really want some kind of default here, like, because I started thinking more and more about build packs where I'm like, I just need bash, and then I scan the code to make sure there's no secrets. And I want to like sort of forcing this, making it mandatory is a limiting factor in a sense. Like, and I could definitely see build packs that just start putting, like, copy pasting this, the Linux and then Ubuntu, and then it's like, oh shit, now I can't use this on CentOS just because somebody copy pasted the Ubuntu thing in. So I think that's why I favor having it as optional, even if that doesn't mean wildcard necessarily.
What about on Windows, using that as an example, right? I feel like bash being on Windows isn't completely unheard of, but I'm not sure.
Yeah, you even have a different script though too. I was actually wondering if, like, and I haven't done any Windows build packs, but like I have written tests for them, and you can just have like bin build and bin build.bat together. And so I wonder if, we want mechanisms where it's like, yeah, I just spit out both build packs or whatever.
So how about smart default? If their Linux scripts are there, then and there's no OS Linux targets, then we add a target that's OS Linux Arch x86 64. If the Windows scripts are there and there's no Windows target, we add the target OS Windows architecture x86 64.
So who's doing that?
The life cycle. Pack sometimes, maybe. I don't pack when it runs create package.
Pack, right?
Pack, yeah.
The stuff. Okay, that makes sense. Yeah, we could do that, right? And that could be like a utility. The utility itself could determine what it should be, but because those are mandatory, we could at least pack say that that's the default, and it could get smart if they wanted to. That makes
Yeah.
sense.
Are distributions optional here? So can you just say Linux and x86-64?
Yes. Distributions are
Okay.
optional, versions are optional. So if you just specify distribution Ubuntu, it'll work on any version. It'll build an image for the target that works on any version of Ubuntu. If you don't specify distributions at all and just say Linux x86, it'll build a copy of the build pack for Linux x86 corresponding to that target.
Okay, because to Joe's point, I was just thinking about if you get a drive-by PR for your build pack because someone has tried it out on ARM and it works fine, and they add a target, are we going to stop adding the Linux x86 if they add ARM? Is that like a weird upgrade path that someone comes by and adds target ARM because they know it works on there, and then now it's not working for x86? And how easy is that to fix?
If they don't have a targets list and then they just add ARM, it will break. But hopefully in that case, it'll be obvious that they
Yeah.
added a targets list and the targets list only has one thing in it. If that makes
Yeah,
sense.
exactly. And if
I
they add
feel-
the target for x86, I'm just making sure it won't like suddenly be restricted to like, only, they're not copy pasting Ubuntu in and then like breaking it for all of CentOS or something.
One thing I think might be good to do is I wonder if we could break the packaging parts of this out. Mostly because we don't, in the distribution spec, sort of talk about multi-arch build packs yet. We need to define that. We have, like, what does it look like when you're running packaging with package toml and pack? I feel like that gets a little confusing. Like, now do we need a way to provide multiple compiled versions of the build pack? Like, I think there are details there we need to work out. And I want to do it, but I wonder if this RC is better and can go through sort of just as a description of build pack compatibility with the stack that doesn't touch on how multiple versions of it get packaged.
The problem, I think I agree that the RFC can leave the complexity of packaging as an unresolved question. The problem I have with not mentioning packaging at all is that targets list isn't, it's not I would use a different format if targets wasn't intended for packaging, because targets lets you repeat, like you can say, like if you wanted to build two build packs, one that works on 1804 and 2004, and the other that works on 1404 and 1604, you would list multiple targets, right, with the different version combinations. So it kind of, the format describes the packaging. It doesn't describe the compatibility, but as long as we're okay saying, yes, it describes the packaging, but we're gonna punt on how that packaging happens, right?
It
And use
also describes the compatibility, right? Both. It describes both. Because like if it only described the packaging, I would say we should be moving it to package toml, right? And replacing our platform field that we have there. We're probably gonna have to get rid of that anyways in this case.
Well,
But
we
I
said
think-
sorry, go ahead.
Yeah. I feel like you need to then move the package toml stuff in here to make this something coherent and implementable, or you need to move this over there. But it should be here because it's also for compatibility. It's not just for packaging.
We always said we wanted to get rid of package toml eventually, once we had a registry, and now we have a registry. So I wonder if that's something to think about.
Yeah. I'd love to get rid of package toml.
And just so I'm clear, kind of on the same lines, we're kind of defining this, but also in mind with like the actual distribution of it, right? Like of it ultimately landing in an OCI registry, right? And that's why we're looking at these, how the config's gonna look and all that. And then when we talk about this multi-arch, right? Just so that I'm clear, we're saying that we would have different config blobs, right? And manifest list that basically points to all these different architectures where it could be. But then from a optimizational perspective, we would still leverage the OCI aspect where the binaries themselves live in a single blob, right? So the manifest is pointing to maybe just a handful of blobs that are the same across all these different manifests.
Well, so the idea is that an entirely separate bin build and bin detect, separate build pack blobs get produced for each architecture because, for each target, because you're probably, if they're binaries, you're going to want to build different versions of the build pack for each architecture, right? They're not going to all run on, the same bin build written in Go isn't going to run on Windows versus Linux versus, or Linux x86 versus Linux ARM. So the idea is that they are separate build packs.
But that doesn't, that's not mandated, right? Like if we look at the script one, right? Like if I just wanted to bash something and script it, you would have one for Linux and you could have one for ARM. And the blob, the contents of the binaries could be essentially the exact same.
Yeah, and they would be the same. They would have the same digest in the end.
That's what I'm saying. So
Right.
we would be averaging if there's no need
Yes.
for
Yes.
Okay, cool.
That's true. Yeah. They would be different manifests. They would have different config blobs, but the config blobs, if the bits are the same, would happen to point to the same bits on the registry because we make sure the timestamps are 0 and all of that stuff. It's not like we're going to be packaging it. Yeah, definitely.
Then I guess in the daemon case, you need to specify exactly which target you're building.
Can we just ignore the daemon case?
I hate the daemon case. I'd love to kill it.
If this drives out killing package toml too, then that's a good outcome for me. I think that adds too much complexity.
Yeah, I definitely want to talk about it. I'm not sure exactly how feasible it is to kill it, but it'd be interesting to discuss.
I mean, all it specifies
Even
is
if we still needed the things in there, I kind of want to roll them into Buildpack toml. I feel like we're not getting a lot of value out of that distinction.
So the problem is referencing, right? Is that Buildpack toml could reference other build packs by name, but not by location. And package toml references by the location. So that's kind of the necessary separation right now. So I'm not sure exactly what the proposal is to resolve that.
when we came up with package toml, we said that once we had a registry and the locations could be looked up by ID, that we would move it into Buildpack toml and then just allow location overrides in Buildpack toml for things that aren't available on your registry. That was the plan for package toml. It was supposed to be temporary.
So when I want to do a packaging of a build pack, right, then I could basically say, okay, go look it up based on this other mechanism. And that mechanism could then say, okay, if you're looking for this name and version of build pack, you're actually going to find it here, right? Like do lookups. Is it, I guess, are we thinking like Linux repos sort of mechanism where you could have lookups based on repos?
I see it like a gem file. Like, in a gem file, you see rubygems.org at the top, and then you just list your gems. You don't specify where they all live, but you can override their locations to point it to like, a specific Git repo to pull a gem, right? That's what I imagine Buildpack toml looks like. It points to the registry.buildpacks.io by default. That's where it looks up the download locations of all the build packs by ID and version. If you want to do a custom one, then you can do an override in Buildpack toml itself saying, actually get this one from here. But we could also support package toml forever as like the separate source. Yeah, exactly. Right. If you didn't want to put your overrides directly in Buildpack toml. Maybe for enterprise packaging. Sorry, go ahead.
I got one last thing I want to throw out before we run out of time here about this proposal. Is it okay if I change the topic briefly? Rebase and Cyclone DX. I think we should not put Cyclone DX into the workflow. I'd rather use I think this label needs to be renamed the IO Buildpacks ID, because like what ID is it referring to? I think on some level we need to keep the word stack around, but I'm willing to talk about other words for it. We need a word, I think. But I think it's fine if it's optional, but you should have to force unless they match. Like optional means like go ahead and rebase it. I mean, if the thing is set and they match, that means you can rebase it without forcing. Otherwise, you always have to force. I like that because it's simple. And now that the stack ID isn't doing a lot of other work, you can just use that as a way of indicating that any two images can be rebased out from under each other. Like maybe it doesn't tie build to run. Maybe they're not the same ID. It's like any run image with this ID could be the base layers. They could all be swappable.
Sorry, if I highlighted an ID a second ago, it was because I wanted to remember that I didn't talk about that thing, not because it's related to that SBOM part. The SBOM part is separate. I forgot I was sharing.
Yeah,
So
I want to kill the SBOM part as being a functional part of rebase. Like
Yes.
SBOM should just be metadata.
Yeah.
And then use the ID as a way of making sure as a stand-in for package base image compatibility.
So all this says right now is that if there is an SBOM, if there's a merged SBOM, PAC is allowed to use that as a convenience feature, not part of the spec, right? In order to warn you if you're doing a rebase that's bad. I left the Cyclone DX example in there to show, yes, it can have packages in it. And yes, we could warn like this, but it's not, it's part of the RFC solely because it's saying we had validations before, now we basically don't. But here's how a platform could take advantage of metadata that may or may not be on the image to warn you if you're doing a rebase that's bad. But it's not specified. It's not something that anybody has to implement anywhere, right? It's just a convenience feature for PAC. So then separately from that, target ID is not related to rebase validations. It is just information that goes from the run image to the so I didn't mention, but I exposed all those things from the run image into the build image during build time. It's just information about the run image that got selected. It's not for rebase, doesn't have to do with validations. This still has zero validation, zero mandatory validation on rebase. Is that?
I like zero mandatory validation, but I wonder if we were talking about optional validations in PAC. Like, I think that is a thing that this ID could be used for rather than coupling it to a bunch of BOM complexity. Like, I think that would actually make a lot of sense as something to do.
Yeah, I'm not sure I like having such a strict coupling between build images and run images where they both have an ID and the ID. Oh, you just mean,
you don't need
sorry,
it on build, just run images.
You just mean across different run images. We could also check the ID. Yeah. I think that's fine. I think it says
but
somewhere,
not check packages at all. Like this is a way one could use the ID. It means like these images, they can all be used similarly. It doesn't mean anything other than that.
I think they're kind of separate use cases for me. So like one is like somewhere it actually says that all this metadata is checked. I don't know if I included target ID above, so I should be clear that yes, the idea was if any of this metadata changes, there's a rebase complaint. It's a problem. So I think that should be part of it. 100% sold.
Forgive me for not having read all the text here yet.
No, I think it's not clear because it says base image metadata. It doesn't say whether it includes this optional piece that's only the runtime metadata, like because it's not okay. Anyways, that's fine. This is different though. The SBOM check is just occasionally you're publishing run images you're getting from upstream. If you were to mess up and your run image was different than it was in a previous build and had the same metadata, it's an optional way PAC could validate that yes, you really have something that claims to be ABI compatible with the next build. It's just extended validation, right? It's not, in addition to validating the stuff, it doesn't need to get implemented first, right? Could be optional. Could be PAC rebase -- strict, right? If we wanted to. Just wanted to mention.
I just worry. I'm not even opposed to the idea. I just worry a bit about having this in the proposal because then it's tying it to a bunch of things that will be confusing for people. Like, where are we getting this from? Why is it in Cyclone DX if we haven't approved that yet, or we haven't talked about how to look up the SBOM? Like, I think it just might be simpler for people reading this in the future if we leave out something that's has the potential to change a lot, and then we could add it in later.
It doesn't say cyclone. It just says, here's an example cyclone SBOM. And it says that
Yeah.
if any SBOM is available, the platform can warn if it doesn't match, right? If you want me to take off the example of a cyclone VX SBOM.
Okay, we can leave it, but I worry a little bit about it. But if everyone else feels like it's not confusing, then it's fine.
It was very interwoven in the RFC initially, so I understand
Yeah.
the resistance, but I tried to take it out as much as possible in this most recent thing. I know we're quite a bit over time, so I think we should call it. Thanks everybody.